Okay, let's look at the second example. Just now that is the example 4. Okay, not example 1, this example 4, and this example 5. Okay, let's look at example 5. Okay, try to analyze the function. Okay, so when we went through integration, we have no problem to integrate, but before integrate, try to check the interval. Okay, so this interval, basically this function 1 over x squared, is actually having a problem when the x is 0. Okay, so when you have the x is 0, so you will have a problem. So basically, the one that will give you a problem, which says that it's actually discontinuous. Okay, that is the point where this function is actually discontinuous. So this discontinuous at x equal to 0. Okay, so okay, let's just copy back the questions. Okay, so as I said that whenever you find out that actually there is there is a point that gives you a problem. Okay, change the point with a t. Okay, so this change it to t. So approach to this 0. So approach to this 0, and you will have t here, and it's minus 1. Okay, so just change the t. Okay, change the 0 to t. Change the 0 to t. Okay, so against, okay, this is actually on the left. Okay, so that's why we are on the left here. Okay, so this limit is actually from the left. Okay, so from the left. So for simple, okay, we just take the one that is on the top as left limit. Okay, take the one at the top as left limit. Take the one at the bottom as a right limit. Okay, when we say left limit means that you have a minus on the top. Okay, so okay, let's focus back on this case. Okay, so let me copy back. Okay, so this form is actually a very easy way. There is a very easy way to integrate. So just change it back to -2, and you can do the integration as normal. Okay, so okay, so you integrate x minus 2, so we have x minus 1 over minus 1. All right, okay, and simplify it. So this is negative 1 over x. Okay, I write back the t and minus 1. Okay, so okay, let's sub the t into the equations. So now we will have minus 1 over t minus v minus 1 over minus 1. Alright, we just do the substitution. We did not do anything else. We just do the substitution in here, and we do the substitution in here too. Alright, okay. Again, simplify it. Okay, and minus and minus back will give you minus also. So we have minus 1 here. Alright, okay, so let's just sub the t approach from the left. Okay, for this case, okay. So before we substitute, there are some concepts that you need to know. Okay, that is let's look at the limit. What happens if we are pushing from the left, and what happens if we are pushing from the left and from the right? Okay, so this is basically back to your basic calculus one. Okay, so you're approaching to the number, the point of 0. Okay, so Of course, when we're talking about number line in here, we have -1 and we have 1 here. Okay. When we're talking about approaching from the left, okay, that is your left limit, okay, of this one. So basically, okay, you can even say getting nearer to the 0, okay. So for instance, okay, you can get a number that is very close to 0, that is negative 0.0001. Okay, what happens if you swap the x as negative 0.001 into here? So you will have a negative number. So we have a negative number. So by using this concept, we know that the answer is basically end up with negative infinity. Okay, for the left limit, we are pushing from the left. So try to imagine we take a number, okay, that is very close to 0 from the left. So you submit here, so we have a negative infinity. Okay. And for this case, okay, so let's say you have another number, okay, and it's approaching to 0 from the right. Okay, when we are approaching 0, okay, from the right, okay, so we get a very near number, or very close to 0 number. Okay, let's assume that this number is very close to 0. So you sub it here, okay, so when you sub it here, so you will have a positive number. So as a conclusion, we say that we will have a positive infinity. We will have a positive infinity for this case. So this is the case that we are trying to approach the 0 from the right. Okay, so we have 2. So in our case, we are in the case of approaching from the left. Okay. Initially, we already have the negative. This is already have the negative. You can put the negative outside. So let me rewrite it. So we have the limit 1 over t, so -1. I'll just put this negative outside, okay, and I have the limit. This limit, I gave it to the 1 over t, okay, and this is actually approaching from the left. We are going to follow this case. So this case says that you will have the answer of the minus infinity. So initially we already have the minus, and this is following this case, so this is actually minus infinity here at the end. Alright, okay. So we have a minus infinity from the top, okay, from the definition, okay, from this, okay, from this left limit, okay. So infinity minus you have a positive infinity minus with 1 is still infinity. So you have an answer in terms of infinity. It says that you do not have a finite number as your answer. So we say this limit does not exist. And when this limit does not exist, this is divergent. Right? Okay, let's look at the last example that we have. Okay, so again, so we're going to look at this function. We're going to analyze, okay, the part that will give you problem. Okay, so between these two numbers 0 and 1, the one that will give you problem is actually the 0. Okay, so that's why we will say that actually your function that is ln x is discontinuous at x equal to 0. So okay, now let's just copy back the questions. And remember, okay, every time we're going to substitute the one that give you problem with the t. So you have a t approaching to 0. So you have 1. This is actually a t. Okay, the rest will be the same. Okay, we basically just change the 0 to t. And okay, so this is at the bottom. So at the bottom will be a plus. Okay, this number is at the bottom. Okay, or we can say that okay, it's on the right hand side of the region. Okay, so this is actually a plus. All right. Okay, so now, okay, if we want to integrate this one, so we'll back to our basic. Okay, back to our basic again. So we're going to use the react. Okay, so what we have here is you have the ln x first. So your ln x will be your u, And your dx, 1 dx will be your algebra. Okay, your algebra, that is your dv, your dv. Alright, okay. So differentiate on this one, you will have du is equal to 1 over x, and integrate about this, you will have v equal to x. Okay, so just copy back this. Alright, okay. So now we have uv here minus v du. Okay, and do the substitution. Okay, so the u is ln x, the v is actually x, minus the v is x, and the du, oh, I forgot to put the dx here, so we have a dx here. Okay, so we have 1 over x dx. Alright, okay, simplify it. Okay, simplify it. So we have the x here, so x ln x. Okay, so cancel the x with 1 over x, so we have integration of dx. Okay, and integrate it one more time. So we have minus x. Alright, okay. So now we have complete the integration, and don't forget to put parts the interval. So we have 1t here. Alright, okay. Sub it back. Okay, so sub the value back. So here we have the 1 here. We have 1 here. And you have ln 1 here, okay, and we have 1 here, okay, minus with the t, so the t here, t ln t minus the t here. Again, ln 1 is actually 0, ln 1 is actually 0, okay, and simplify it one more time before you deal with the limit. Alright, okay, so we have minus 1 minus t ln t minus we have a plus t here. Okay, give the limit to those involved with the t. Alright, so I give this limit to this. So I have limit t approach from the right, t ln t. Again, give it to here, so we have plus limit t approach from the right. Alright, okay, so give this limit to here. Right, okay, so let's just look at it separately. Okay, in here we have a form of this one. Okay, so this is basically a form that will give you a problem. Okay, because we have a 0 multiply with negative infinity. Okay, basically you can take the ln. Okay, it's actually using the same concept where we're talking about the limit approaching from the right. Okay, and we're talking about ln. You can pick a number, a very small number. Okay, so for instance, you can think of the x as 0.0000001. Okay, wherever you will substitute here, so you will get a quite big number, but in terms of negative, that's why we have a negative infinity here. Alright, okay, so that's why when we substitute the t approaching from the right in the ln t here, so we have a negative form. Right, so this is a form that you have to manipulate before using the L'Hopital rule. Okay, so modify it just that you can use the L'Hopital rule. Okay, just copy back the limit, and okay, drag down the t. So you drag down the t, So we write it as this way, 1 over the t. Right? Okay. This one I'm going to write it back. Okay. For this case, you have no problem to substitute the t as 0. So we have a plus 0 here. All right. Okay. So okay, let's just analyze back on this form. Okay, if you analyze back on this form, we will have a form of negative infinity over 1 over 0. 1 over 0 is infinity, so you have infinity over infinity. Okay, so that is the time that you're going to use the L'Hopital rule. Okay, so before you use the L'Hopital rule, make sure that they are in the form that will be easy for you. It will be easy for you to do the differentiation. Okay, so the ln, just keep the ln, but I can rewrite this, okay, as t minus 1. I'll just rewrite the form plus 0, just leave it. Okay, let's just apply the L'Hopital here. So if you apply the L'Hopital here, so ln t, if you apply the L'Hopital, so you have 1 over t. Okay, what happened to here? This one you will have minus t minus 2. Okay, so basically L'Hopital are here. Alright, okay. So let's just simplify the things that we get here, right? Let's simplify. Okay, so minus 1 minus the, okay, this is, I can rewrite it as minus 1 over t squared. Okay. Okay. So minus 1 minus limit from the right. Okay, because this is 1 over t. Okay, this is actually minus t squared over 1, right? And again, simplify it before you do the substitution, before you sub t at 0 into your equations, right? Okay, so just copy back the limit one more time. Okay, and you can cancel out. You can cancel out your remaining of minus t here. So minus t is give you a positive. Okay, minus minus. We have a minus minus here. We have a minus minus here. That's why we have a positive here, right? Okay. So now we have a t here. So let's just substitute the t. Okay, we substitute the t with a 0. So we have a 0 here. So at the end we have minus 1. So since that you have minus 1 as the answer, we say that limit exists and it is convergent. Okay, so that's the answer for example.